Okay, so chapter 2. I showed you in chapter 1 how you do sine, cosine, tangent. Those are really nice. The problem is those only work for triangles that have a 90-degree angle. If I have some other angle, if I have 3 angles here for A, B, and C that are not 90, I cannot use SOHCAHTOA. So everything that you've learned about SOHCAHTOA is only for triangles that have at least, well, not at least, that have one right angle. So you can use a calculator, you can do these, that's easy. What I'm going to look at now is what's called the cosine law. And this cosine law works for triangles that do not have 90 degrees. So this equation's a little blurred, but essentially what it is it's c squared equals a squared plus b squared minus 2ab cos capital C. So lowercase c, capital C. And this is from looking at the triangle here, making sure that capital C is the angle, lowercase c is opposite that. Capital B, lowercase b, and so on and so forth. So we need to use that to solve some equations. So notice with this, I showed you that it can be varied. So as long as A and capital A are the first and the last in the equation, you should be fine. So let's try it out with something like this. So we want to know what is the distance across this lake, given that when I'm standing at point C, I measured to one side of the lake as 120, I measured to the other side of the lake is 250, and the angle in between that is 62. So this is actually a great way how you can calculate something when you can't actually walk from A to B, because no one can walk on water. So if I want to find length C, I'm going to use the equation that I just have. So c squared equals a squared plus b squared. Notice this is just Pythagoras. But again, Pythagoras does not work for non-right angle triangles. Minus 2ab cos capital C. And then we plug in numbers. So a, lowercase a is opposite capital A. Lowercase b is opposite of capital B. We got 250 squared plus 120 squared minus 2 times 250 times 120 cos capital C, which is 62. And that's equal to c squared. A very, very common mistake in this is forgetting to square at the end. So if you plug all this in your calculator, you'd get 48,731.7. But this is equal to c squared. So you need to take the square root, which would give us 220.8. And this is in meters. Again, just for the sake of logistics, because I did the square root, technically there should be plus or minus, but we're not going to count a negative distance, so we're just going to use the positive values. So that's how you would use the cosine law. Something like this. And this is important whenever you've got an angle in between two sides, or you're given all three sides. Let's try a few more examples here. So let's do this one. Actually, no, I'm going to do this one, because this one changes the variables around. So here we go. Angle stuck in between two sides. The reason why this is important is when we get to day 3. I'm going to show you a different configuration. So for this, we want to find this side, which is lowercase a. Here's lowercase b, lowercase c. So to solve this side, I'm going to change the equation. So I'm going to get a squared equals b squared plus c squared minus 2bc cos capital A. Notice again, all that matters is A and A are first and last, or B and B are first and last, or C and C. So plug this in. 50 squared plus 75 squared minus 2 times 50 times 75 cos 30. And again, plug that into your calculator. Take the square root, you get A equals 40.4. Oops, there we go. 40.4. So that is that. We can also use this equation and, wait, that one's too big. I can't show it on the screen. I'll do this one. We can also solve for angles. So here we want to solve for C. So this side would be lowercase c, lowercase b, lowercase a. We get c squared equals a squared plus b squared minus 2ab cos capital C. Plug in what we know. 52 squared equals 14 squared plus 70 squared minus 2 times 14 times 70 cos capital C, which is what we're solving for. So in order to do this, first I'm going to subtract the squares. So 52 squared minus 14 squared minus 70 squared. This would give us negative 1,588. Equals, and negative 2 times 14 times 70, so I multiplied those together, I get negative 1,792 times cos capital C. Divide by negative 1,792, I get cos C equals 0.886. Again, use the answer key in your calculator, the answer button. Don't round this. If you round, you're going to get some weird number. So take the inverse cos of this, and we get that angle C is equal to 28 degrees. So there you go. There is your angle. So you can also get word problems for this. Don't do B. It requires the sine law, which I haven't shown you yet. But I can solve for one like this. So we're told a radar station is tracking ships. So one ship is 45 kilometers away. The other is 3.3 kilometers away. And if the angle between them is 100, how far apart are the ships? So let's draw a picture of this so you can see what's happening. So here's your radar station. They see one boat that is over here. Let's say this one is 3.3 kilometers. They see another one that's way down here. Yes, I know my ships look like houses. So this one is 4.5 kilometers away. And we're told between them here is 100 degrees. We want to know what is the distance between them. So once you draw the diagram for this, it's really not too difficult. Because we've set up the triangle, now we need to actually solve this. So I'm going to label this. Let's say this is capital C, capital A, capital B. Doesn't really matter. So this is lowercase a, lowercase b, lowercase c. We need to solve for lowercase c. So c squared equals a squared, which is 4.5 squared, plus 3.3 squared, minus 2. I'm going to shift this over so you can see the full equation. 2 times 4.5 times 3.3 cos 100. And then solve for C. So C will be 6.0 kilometers. Again, don't forget to take the square root. So there you go. Word problems. Make sure that you are drawing out a triangle for this. That's the nice thing about drawing these out, is you'll need to, it has to have a triangle in there somewhere so that you can be able to solve that. So that is chapter 2, dealing with the cosine law. Next section, we're going to talk about the sine law.